One more exercise before we go for a break. Check this one, the last one. It's question 8. I hope it's clear on your screens. In the diagram, ST parallel to QW and PQR is a tangent to the circle. PQR, check, it's given. ST parallel to QW and they are indicated. Thank you. And PQR is a tangent to the circle QSTVW. QSTVW. That clearly indicates that those points lie on the circumference of the circle. Then W1 is equal to 70 degrees. Where is W1? The given information. Here is this angle. You indicate the given information on the diagram. This angle is 70 degrees. It's given. And Q3, what is Q3? This Q, here is angle Q3. This Q3 is equal to 30 degrees. Indicate the given information on the diagram, if it's not indicated. Now that it's we have indicated it, let's answer the questions then. The first question, calculate with reasons the magnitude of the following angles. Angle V, here is angle V. You need to determine the size of angle V. Q1, you need to determine the size of Q1, Q2, and T1. And there is angle T1. 2 is 3 marks, it's 5 marks, it's a mark, it's another 2 marks. All in all, this question takes about 8 marks. So I'll be happy if I can give you 5 minutes to work on this one. And then after 5 minutes, I'll then carry you through to the solution so that we can then have a break. And then after a break, we'll then carry on with the grade 12 geometry. For now, for the next 5 minutes, find the solution to this one. Thank you very much. Welcome. Let's determine the solution to this one. Thank you. Remember the given statement. In the diagram alongside, ST is parallel to QW, and they are marked. ST parallel to QW. The two parallel lines are marked. And PQR is a tangent. PQR is a tangent. Angle W1 is 70 degrees. We have marked it. Q3 is equal to 30 degrees. We have marked it. The first question, calculate the size of angle V. Look at the diagram. Look at the angles that relates to angle V. Especially try to look at the angles that we know their values, their magnitude, their sizes, and then we try and relate them to angle V. If you can check, angle V is related to angle S1 because TSWV is a cyclic quad. I repeat, TSWV is a cyclic quad. So if TSW is a cyclic quad, it means opposite angles are supplementary. But we don't know the size of angle S1. Let's determine S1 first. 8.1.1. 8.1.1, check S1, check W1. We say S1 is equals to 70 degrees. Why do I say this angle was that angle? Because we've got parallel lines. We know once we have parallel lines, alternating angles will then be equal. Therefore, S1 is equal to W1, which is 70 degrees. The reason is that TS is parallel to QW. Therefore, those are the alternate angles. Alternate angles where TS is parallel to QW. So it means S1 here, we've got 70 degrees. Now we can relate S1 to V by saying angle S1 plus angle V, they give us 180 degrees. Let's provide the reason for that statement, because these are the opposite angles of cyclic quad. These are the opposite angles of cyclic quad. The opposite angles of a cyclic quad. Let's substitute. S1 is 70 degrees plus angle V, then you've got 180 degrees. Therefore, it means our angle V will be equal to 180 degrees minus 70, which will give us 110 degrees. We are done with the value of V. Therefore, it means V here we've got 110 degrees. Hope you are happy with the solution to the first one for 3 marks. I hope you are happy with the solution for the first one. Check the second one, Q1. 8.1.2, determine Q1. Where is Q1? Here is Q1. How can we relate Q1 to any of the angles that we know? Check Q1. Remember, PQR is a tangent. If PQR is a tangent, Q1 becomes an angle between a tangent and a chord, and W1 becomes an angle in the alternate segment. Meaning that for us to determine to find the solution for 8.1.2, 8.1.2, the solution will then be Q1 is equals to W1. Q1 is equal to W1. This is tan-chord theorem, according to tan-chord theorem. Therefore, it is also equals to 70 degrees. This is according to tan-chord theorem. Tan-chord theorem. The angle between a tangent to the circle and a chord drawn from a point of contact, that angle is equals to angle in the alternate segment. So Q1, where is it? Here is Q1. We've got Q1 here as 70 degrees as well. 8.1.2 answered. 8.1.3, we are required to call it Q2. Remember, PQR is a tangent. A tangent is a straight line that touches the circle at one point only. So let's calculate Q2. 8.1.3. If you look at the diagram, angle Q1 plus Q2 plus Q3, they give us 180 degrees because PQR is a straight line. PQR is a straight line. Let's go. It means check angle Q1. We said Q1 plus Q2 plus Q3, all these angles add up to 180 degrees. Those are the angles on straight line. And angles on a straight line add up to 180 degrees. Remember, Q1 is 70 degrees. We want to calculate the size of Q2, and Q3 is equal to 30 degrees. It is given. It is given. So all we have to do is to transpose 70 and 30 to the right. 70 plus 30 gives you 100. So on the left-hand side, we want to be left with Q2 only. So 70 plus 30, 100, transpose it to the right. Then we have 180 degrees minus 100 degrees, which will give you 80 degrees. Then we are done with the value of Q2. I hope you enjoyed that one as well. 8.1.3. Let's check the last one, T1. T1, where is T1? Here is T1. look at any angle that relates to T1. Any angle that relates to T1, especially the angles that you know their sizes, the angles that you know their magnitudes. So already remember we said Q2 here, we had 80 degrees. Got 80 degrees. So immediately T1 and Q2, they relate because TSQW is a cyclic quad. It's a cyclic quad. As a result, the opposite angles are supplementary. Then it means this 80 degrees plus T1, they should give us 180 degrees. They should give us 180 degrees. Those are the opposite angles of a cyclic quad. Let's solve 8.1.4. 8.1.4, we said 1 to T1, angle T1 plus 80 degrees. They give us 180 degrees. T1 plus 80, let's check. T1 plus this 80 of Q2. T1 plus this 80 of Q2, they give us 180 degrees. Those are the opposite angles of a cyclic quad. Let's write the reason opposite angles of cyclic quad. Now we can solve T1. Therefore, T1 will then be equal to 180 degrees minus 80, which will give you 100 degrees. Thank you very much. I hope you have enjoyed the few exercises that we did together. I'm going to give you a 5 minutes break just to refresh a bit, and then after 5 minutes we'll then continue with more exercises on Euclidean geometry, but the more focus will now be on those grade 12 theorems, similarity theorem and the proportionality theorem. For now, I thank you.